So, I have my cheat sheet. I have my exam paper. And I'll be talking to you about how to look at reading time. So, are you ready? We're going to go now. So, all questions for both areas. G should be 10. Awesome. So, in reading time, the main aim is to get an idea of everything. You want to see as much as you can to go for your strengths and let your mind kind of work on the questions you don't really know how to do. So, talk about towing a ship. Question 1. Okay, so situation is we have something pulling the ship forwards. This is resistance, and this is speed. So the faster this thing is moving, the more resistance is happening against this. So that's F equals ma. So that's when the force forwards equals the resistance. Circular motion, battery current pass, its mass of 2.4, gives a constant speed of 2 meters across the mass. What is the tension in the string? You must show you're working. So this will be, well, it's a circular question, and we're trying to find like how much force is happening. So usually that's a mv squared on r. So that's what I'd be doing later. Arrows L to B indicate the best direction of the resultant force. Well, we know that for it to be moving in a circle, it must have a central acceleration, which is v squared on r. V squared on r. V squared on r. So that should be it. So I'm just quickly getting an idea of each question, making myself a little plan on how to solve it, and then I'll come back afterwards and have a look at them. So this is a projectile motion question. It'll be shooting up. What is the maximum height the ball reaches? You must show you're working. So essentially, I know I can find the vertical upwards initial velocity. I have the acceleration, and then the final velocity is v0. So I can use v squared equals u squared plus 2ax. Because I have v, u, and 2. All I need is x, a. So I need x. So I can solve that. Let's represent the resultant force on the ball at point x. So the force will just be gravity. I know it's moving in this direction, but it's only going down because we're ignoring air resistance. Is now placed on the boundary of the cricket. Assuming the ball is 6 in the same. What height will the ball strike? The advertising board. You must show you're working. So, in terms of any question where they show a projectile hitting a wall, this means you can't figure out the time using height. Because most of the time, if we have something hitting the ground, we know how long it takes. Or if we know it goes up and hits, it reaches the maximum height, that's all in the vertical. That's vertical acceleration velocity. Everything's vertical. And we have enough information to figure out time from that. But because this is hitting a wall, that tells us we should start with horizontal and get our horizontal information. So in this case, we would have velocity, distance, acceleration equals 0. That means we just need to use this because we have the distance, we have the initial velocity, and we have acceleration in 0. Therefore, we can find time, and then we put time into the vertical velocity to give us the height. Locomotive of mass is moving east. Stationary. So this sounds like a momentum question. When I see something like this, it looks like a momentum question before, after. It could also be energy. Yeah. So this one's not moving. This one hits. This momentum and couples to 3 trucks each of there. This has the momentum. This is initially 0, and then they combine, and we find a new velocity using momentum equals mv. What is the impulse given to the locomotive by the trucks in the collision? Magnitude, direction. You must show you're working. So we could find the momentum of the truck, of the train afterwards, and the train before, and the difference would be the difference in momentum, and that would be the impulse. Was this collision elastic or inelastic? Support your conclusion by appropriate calculations. Now we just figure out the energy of the initial situation, because elastic means sorry. Yeah, so elastic collision means there's full maintenance of kinetic energy. So all we need to do is figure out the kinetic energy of this, the kinetic energy of this, and see if they're different. If they're the same, then the collision one is elastic. So we'd use the half mv squared on this, and then half mv squared on this. During the collision, the magnitude of the average force is Ft, and the magnitude of the average force is F little t, F big T. No, FL and Ft. Will FL be greater, equal to, or less than Ft? Ooh, interesting. So, if the locomotive exerted this much momentum on the trucks exert the same momentum back on the locomotive. Yeah. Well, let me check that. I'm not sure. But I think that's what would happen. I'd have to look at it later. But because it's reading time, and I haven't read this before, what you do is, if you're not completely sure, move on. You can think about it later. The spring question. So the string stretch is 60 centimeters. Okay. Not oscillating, so 60 centimeters is where mg pulling it down and kx pushing it up are equal. Okay, so we use half kx squared here, because that's the energy of the spring. So if we want to convert energy backwards and forwards here, half kx squared is the energy of a spring. We know K is 10 newtons per meters minus 1. And we know X is, well, since it's usually 40 centimeters, now it's 60 centimeters. Importantly, this is going to be, we have to measure in meters because K is in meters. So this will be 0.2 meters. So it'll be half K 10 times 2 squared, half Kx squared. Let's skip it for now, but I know I can do them. Shows the orbit around the sun. Determine how the speed and total energy of the comet varies as it moves around the sun. Oh, interesting. So, so basically this will be a radius question. So we want to know the speed and kinetic energy. So I know v squared varies. We could use this. Hard to explain why. But basically, we know that gm1 on r squared equals v squared on r, because this is our gravitational formulas. So now if we take the r over, it would be gm on r equals v squared. Essentially, we want to know, because the radius changes here, we want to know how velocity changes according to the radius, how they vary together. So according to this equation, if we take this r over, we get gm1 on r equals v squared. I might write it down now, just to help you guys have a look. Therefore, as the radius gets really big, v squared gets smaller, so it's slower over here and faster over here. So the speed will move faster, and the total kinetic energy, our total energy will stay the same because of potential energy, but kinetic energy will increase. Calculating the gravitational force. All we need to use is our force formula. One of these three. This is if we have mass. This is if we have velocity. This is if we have the period. Calculate the period of the orbit of the surveyor. So we're given masses. So we want period in terms of mass. All we need to use is convert mass to period formulas. gm on r squared equals 4 pi squared r on t squared. We rearrange it and we get t equals something in terms of mass and radius, and we just sub in the values. Easy. So that's a quick 10-minute talk on how to have a look at the first 17 questions of your physics sack. Essentially what you want to do is get an idea of all the questions out there and just go for the ones that you feel very comfortable with, and then come back to the other ones later. You shouldn't go from beginning to end if you find the early ones difficult, because then what happens is you spend a lot of time in them and then you don't get to do the questions you'd find really easy, and you don't get the kind of confidence and momentum happening. Yeah. So I'll catch you guys later. Thanks.